Hi guys, this is Mrs. Gassler, and in this video we're going to talk about how to determine what type of bond exists between some elements. We're going to need some Cornell paper and maybe your colorful periodic table that tells you what types of elements are there and where they are located, because that will be helpful. And let's go ahead and get started. So here's our Cornell paper. Make sure you put your name and date and class period here, and our objective is to determine the type of bond, and we have one essential question. How do I know what type of bond will exist between two elements? So this objective is fairly short because there's two ways that you can look at it. We looked at the properties in the last objective when we were deciding the type of bond based on the properties, and so we're going to look at it from a different perspective here, but let's review what our types of bonds are. First we have ionic, then we have covalent, and our covalent compounds are split up into polar and nonpolar. And the easiest way to distinguish between the two main categories, the ionic and the covalent, is to understand what types of elements make them up. So I'm going to draw a line here and move this up a little. Okay, so for our ionic compounds, they form between a metal and a nonmetal. In any ionic compound, you have to have a combination of a metal and a nonmetal. So when we colored our periodic table with the metals and the nonmetals and the metalloids, remember a metalloid is like a nonmetal. It just sometimes behaves like a metal, but you have to have one from each side of the periodic table, either in the middle or all the way on the left or the right and somewhere in the middle. But you got to have a metal and a non-metal for it to be ionic. So if you have a formula, you can look for the symbols in the periodic table, and depending on where they are, it might be an ionic compound. If you are asked to say, oh gee, what forms between cobalt and selenium, then you would find out what cobalt and selenium are and say whether or not it's ionic or covalent. So the other one, the covalent compounds form, I'm going to write this kind of between them, it forms between only nonmetals. So if it's got a metal in it, it's an ionic compound. If it's only nonmetals, it's a covalent compound. Now there's one exception to that, but it still has a metal in it. Sometimes the metal combines with one of those polyatomic ions, in which case it's got a covalent compound and an ionic compound together. So it's a couple of things happening there. So this is the first thing you would do to figure out if it is ionic or covalent. Now, once you know whether or not it's ionic or covalent, the next thing that you need to ask yourself is whether it's polar covalent or nonpolar covalent. So we'll draw a line here. I'm going to circle this because that's pretty much it. If you know it's ionic, and you don't have to ask yourself the rest of these questions. If it's polar covalent, the next thing that you need to do is, if it's covalent, the next thing you need to do is you need to look at the difference between electronegativity. So I'm going to write that here, electronegativity difference. And there is a chart on the back of your periodic table. This is what it looks like. It's kind of near that, what did we call it? The electron configuration chart. And on this table, to be honest, you really don't need any of this over here, because we don't need to do these calculations when we're talking about the electronegativities. You'll already know that it's an ionic compound because of the fact that it's got a metal in it. So we're going to look at the covalent compounds only for this. Oh, H, I should have left H out here. H is part of the nonmetals. Now, you might notice that there aren't the noble gases, that last column, helium, neon, argon, krypton, xenon, radon. Those noble gases don't form compounds because they're noble gases. So they aren't on the list. So if we're looking at an electronegativity difference, to be polar, that electronegativity difference is greater than 0.5. So if I picked silicon and sulfur, those guys would make a polar covalent compound because the difference between 1.8 and 2.5 is 0.7, and so that makes it a polar compound. To get an or to get a nonpolar compound, it must be less than 0.5. And I believe if it is 0.5, then it is considered polar. For a good example of that one, here's bromine and chlorine. We've got 2.8 and 3.0. Those are only 0.2 off, so that would be a nonpolar covalent compound. I should make those a different color. Let's go with purple. Nonpolar, less than 0.5, polar, greater than 0.5. So that chart is on the periodic table. It will be on the periodic table that you can use on the test, so there's not anything you have to worry about doing there. So that's it. That's all it takes to figure out whether it's ionic or covalent based on its location in the periodic table and electronegativity. If you have any questions, make sure you ask your teacher. Thanks for watching.